All right. Well, we've got a full day, so I'm going to get started. I know we had a lot of people who registered for this class, and so there's going to be people jumping on still, but we're going to get going. We have a full class today. All Q&A will be at the end of class. We're doing Sump and Sewage fundamentals, people. It's going to be exciting. All right. Q&A, as always, is at the bottom of the screen. I monitor Q&A and the chat box, so whichever you're most comfortable with, feel free. If at any time you have any issues, you can either send a message through there. If you keep logging out, I don't know, there's been some tech issues in the past, but feel free to use my email address. I'm watching that too in case people have any major problems, but we should be good. With that, Paul, I'm handing it off to you for this amazing topic.
Yeah, thanks, Sunday. Good morning, everybody. So yes, we're going to cover some fundamentals, as Sunday says, on sump and sewage. We're going to talk mainly about commercial, not a wastewater treatment plant setup. That's kind of out of our realm. Everything we're talking about today is really based on the commercial sump and sewage world. Just moving water out of a building, tying it back into city tie-in. Something very simple. But we see it get screwed up a lot, and there's just a little different mindset as it relates to equipment selection, how we're going to service that, and how we control it. So that's our goal this morning, is just to cover on those fundamentals. And thanks for joining us this morning. We'll try to keep everything. How do I want to say this? We're not going to get nasty on you. Okay, we'll keep everything really sensitive, so your bagel and coffee stays down. Okay, nothing's going to get rough on you,
and you don't have to change your lunch plans.
If you remember, if you attended our centrifugal pump class, coffee can with holes in it and water just flows out. And if we want to develop some pressure in that pump, or we want to be able to spray water out of those holes a little farther or faster, then we start to rotate that can. Okay, and as we rotate that can, we develop some velocity, and now we can send water out to our system. And we do that with our coffee can is our impeller. Okay, and all we're doing with that impeller is handling water that's flowing in. We're guiding it with our vanes and ultimately flipping it towards the discharge. Take that impeller and put it into a typical pump housing. This is what you're looking at for a standard centrifugal pump. Again, all water is flowing into the screen, okay? Holes around our coffee can, and then vanes that direct it out or flip it towards the discharge in this case. Now, if you understand this, you got any centrifugal pump that's out in the marketplace, because they all work the same. Orientation might be a little different. And the only reason I'm reviewing this is because when we get to sump and sewage, we're doing the exact same thing. The only difference is we're taking that volute and impeller that's sitting vertical, and we're going to, well, or horizontal, depending on how you want to look at it, and we're going to tip it up, okay? And you might end up with something that looks like this, a standard submersible sump and sewage pump. And you'll notice that we've got a housing with an impeller inside of it, a motor attached, kind of direct drive. We've got some seals in here. We're going to talk about all that as we go. But water is simply flowing into the bottom of it. We rotate that impeller around and we send it out the discharge. That's all that's happening in in a standard sump and sewage setup. So a couple things. If we're dealing with clean water, which we might call storm water or rainwater runoff, groundwater, anything that doesn't have a lot of solid in it, you typically have an impeller that has multiple vanes designed to pass clean water, not a lot of solid or particulate. If we're dealing with sanitary or sewage, you're going to find most of those have a 2-vane impeller, and the fact that we can pass pretty good solids or particulates through that style pump. That's really the only difference when you look at an impeller sizes or impeller configurations. So this is a good example of an impeller that would pass relatively good sized solids, 2.5, 3-inch solids. And this is a good example of a clean water pump where you're limited in solid or particulate size. You also might hear some terms like grinder and slicer. We'll talk about those in a little bit more detail, but good look at a grinder setup here and a slicer style over here on the right. Let's talk about a standard submersible pump real quick. What's that doing for us? There's a few unique things when you stick a pump under a body of water that you, that you need to protect for. Uh, a standard commercial motor is air filled, meaning there's no hydraulic oil in there. It's simply a motor encased in air, if you will. Obviously, we want that watertight. So you tend to have electrical connections, maybe a temperature probe and a moisture probe. All that gets epoxied at the factory. So one thing you never want to do is to lift on a power cable or a sensor cable because it can break the epoxy lining here. And if that happens, now you have potential to flood your motor with any water that's in your basin. That can be a bad thing. Okay. You'll also notice that we have a seal chamber. And this is a little unique in the fact that we've got a seal chamber that is running in oil, an oil bath, basically. And then there's also a moisture probe that sits in there. Well, if one of the seals fails, we pick up moisture on the probe, and this tells us, gives us a signal back at the control panel that we've got a pump in need of service, and it will actually take it out of rotation. Okay, it's how you monitor a pump that's below a body of water that's out of sight. Is one of the protectors here or safeties. There's also a temperature probe inside the windings. It's looking for elevated temperatures. So if we have some debris wrapped around our impeller, somebody stuck a 2x4 or a mop head down into our basin, and we're drawing excessive amps, that's also going to get transmitted up to our control panel. Okay. Notice this particular pump has a very tall impeller in it. Obviously, we have potential to pass good-sized solids through here as well. The fact that this pump has feet on it would indicate it's a foot-mounted or floor-mounted unit. Okay, maybe not designed for a removal system. We'll talk about that in just a minute. But this is a standard submersible pump designed to pass full-size solids. We can take that same configuration and change it a little bit and go to what we might call a grinder. The difference with the grinder, it kind of, it's got a very skinny impeller, but then also a cutter and a shredding ring attached to it. So as that impeller and motor is in rotation, it's also chopping any particulate up into smaller bits and then sending it out into our discharge line. We tend to use a lot of grinders for if we're trying to get into a high pressure return, maybe an elevated return where you need quite a bit of pressure. Maybe an undersized distribution line where you need to get 2-inch solids into a 1.5 or 2-inch main. Okay. Price between the two, the grinder is actually quite a bit more expensive than a full size or a pump that can pass full size particulate. Might be a little bit more on maintenance as well. Think about a grinder. One way to think about it works really similar to a garbage disposal that we all have at home. Okay, you send debris down your sink. There's actually cutting rings around the inside of your garbage disposal, and then the shaft rotates based on the motor and takes all your food particulate and simply chops them into smaller bits until they flow through your holes and ultimately leave your sink and head on out to either your drain field or your sewer tie-in. Okay. Another style pump is what we call a slicer. And this allows anything that comes into the pump itself to get sliced. You got a fixed bar here on the inlet or the pump volute. You also have another fixed bar on the impeller, but that one's spinning. So anything that gets stuck between those two is going to get chopped into bits as as it comes through. The last one that's a little unique is what we might call a mover or a vortex pump. And this simply uses kind of a skinny impeller that's tucked up into the housing and works more on a vortex setup. So we still move the water, but any rags or wipes that might get wrapped around that impeller don't have a very good chance to do that because the impeller is so skinny. So this works really well for people who are having problems with people flushing baby wipes or hand wipes, any sanitary rags. Obviously, we're seeing that in a COVID situation, a lot of disinfection going on. People don't always pay attention to, hey, don't flush wipes. So when that ends up in our sump, that can wrap itself around an impeller. Excuse me. So there's different ways of dealing with that. One is a slicer, the other one's a mover. They can be retrofitted depending on your application. So if you're having problems, get us involved. We're happy to help. We have a lot of manufacturers that will call their pumps sewage and sewage related or sewage applicable, and others will call them sump pumps. Some will just call them submersible, and it's up to you to figure out which ones you're going to use. It can be very confusing to figure out what pump you should be using. One thing to look at if you're new to sump and sewage is the thickness of the case or the depth of it. If it's a relatively shallow case, it means you're not you don't have a lot of room in there to pass high particulate or high solids, which you tend to see in sewage. So sewage applications, you'll have a much taller case, meaning a much taller impeller, more potential to pass large solids. So maybe from a quick submittal review, you can, just by looking at the case, you can say, hey, this is probably a clean water pump versus something designed for solids. The other thing that might be unique is if you have a clean water pump, there tends to be a strainer on the bottom of it, limiting the max particle size that is going to enter the case or ultimately your impeller. Okay, where sewage is wide open, looking to pick up any debris that's in your sump. Okay, let me launch my first poll. This might stay up for a few minutes, so oh, let's see if I did that right. Hang on a second before I launch my poll. Okay, I might be out of order here. So let me launch poll number 2. Okay, the question is submersible versus vertical column, and that's kind of where we're headed here. So bear with me a second. So I got the poll going. We're just going to talk roughly about 2 different pump types for sump and sewage. One is submersible, which we've kind of been discussing all along here. And that simply means that we've got a pump that's down in a basin, kind of surrounded by water. And as water builds up, we send it out. We do have options for single and double seals. We'll talk about that in just a minute. A typical application for submersible, simply this up at the top of our basin, we're going to consider that grade, okay, or where our parking lot or concrete floor is. And then down below grade is where our water is coming into our basin. And then we've got pumps in there that are reacting to water level as it relates to float activation to turn those pumps on or off. If you look at a column style pump, works very similar, same volute or same housing, okay, same impeller. The difference is now you've got an elevated pump that you can see, and there's a visual on it. Now let's see if I can, this might be a good time to go ahead and end my poll. So forgive me, I thought I'd give you more time. Not happening. Let's share results. Okay, let's take a look at this. What are some of the advantages of submersible pumps versus vertical columns? Okay, so here we're looking at a vertical column versus a submersible that stays down low. Or is below grade level. Advantages of submersible pumps: ease of service for the electrical motor. I'm going to probably not, and the fact that in order to service a motor on a submersible pump, you physically have to pull it out of the basin. An advantage of a vertical column is the motor is above the basin, so it's easier to work on a vertical column. A submersible is less expensive than a vertical column. You would think so, but actually a submersible pump is more expensive. Little to no maintenance required. Yeah, that's a true statement. A submersible pump doesn't need a lot of maintenance. Again, unless somebody's sending a 2x4 or a mop head or a lot of hand wipes, needles. There's a lot of weird things that can that can cause some problems. But if it's considered clean water or filtered water, everything's fine. There's not a lot of maintenance that's required in a standard submersible pump. An explosion-proof motor isn't required for sewage applications. For submersible, it is. For vertical column, it is not, because the motor is outside of the basin. Any potential for methane gas, it's removed from that. So that's an advantage of the vertical column. You would not need that. Saves valuable floor space. This is actually a really big advantage for submersible. You don't have a motor sticking above grade or into a parking structure. And if you're in a condo situation where you're selling a parking spot for $10,000, it's hard to get a car next to a vertical motor. Okay, but having a submersible pump eliminates that issue. And sorry, no idea. No problem. One of the other issues we see, and by the way, thank you everybody for taking part of that poll. One of the issues we see with vertical column is that the column or the shaft length has to be as long or as deep as the basin. So if you've got a 10-foot basin, you've got a 10-foot line length. And a lot of those will have intermediate bearings or lubrication spots. And if that doesn't get maintained or lubricated, now you get a shaft that starts to wobble or gets out of control. You can get a lot of very rough vibration up here near the surface. It might look easy to service, but if you've got to pull a 10-foot column, vertical column out of a sump, you better have some ceiling height above you. Our rule of thumb is we tend to do a lot of submersibles. Vertical column is usually 4 feet or less as far as that basin goes. So we just have to be careful on that application. We used to see a lot of them, but more commonly we're seeing them go away a little bit. There's nothing wrong with them. You just have to be careful on their application. Okay. Sump versus sewage, storm versus sanitary. I think where I'm going here is the fact that we might have some single seal pumps that are designed for 1/2 through 2-inch solids. But anytime we're dealing with sanitary or sewage, we usually want the ability to pass 2 1/4 or larger on solid size. So most commercial sewage pumps are designed for larger solids. And you'll see that their housing is very tall, allowing them to do that. It's also a 2-seal setup. So what are we talking about there? Well, a single seal pump means there's only one mechanical seal inside that pump or that housing. And if the seal fails or ruptures, guess what? We're flooding our motor. And as a result, that pump is no longer able to work for us. Okay, that's a bad day. You would tend to use a single seal pump on a pump that's going to see maybe some intermittent use, like an elevator sump. But you wouldn't put this into a typical application where you need a reliable pump to run 24/7, 365. Okay, so this would be an intermittent use. Most of our commercial applications use something we call double seal. And again, that's 2 seals that are working together. Now there's 2 ways to condition those. One is to have the seal in the, one of the seals is in the oil bath, and the other seal is in the fluid that is being pumped. So this works fine for groundwater or rainwater runoff. May not be the best for sewage. If you've got some nasties in your water, we may want to protect both seals and have them run in a cleaner environment, which is an oil bath. So this is not a heavy adder. I think it's a $50 adder to put both seals in an oil bath versus one in the fluid that's being pumped. Okay, but you could order a pump both ways. All right, so I'm going to move on from this. Yeah, just different seal choices. I'm going to fast forward through this. I know Sunday would appreciate that. Okay, and then vertical pumps. We've already touched on that. I've already ended my poll, so we're gonna continue to move. So forgive me, I'm a bit out of order. I will correct this on Thursday if anybody wants to sit through this again. Oh, now that brings me to my poll number 2, which we called poll number 1. So bear with me a second. Let me launch that poll because we're going to get into pump curves real quick. Okay, we got a poll running. Now, if you're used to standard centrifugal pumps, you're used to reading pump curves, and you could select this with software or actually look at a hard curve. On Sump and Sewage, most of these are going to tell you the discharge size of the pump. It's also going to tell you a max sphere or solid size that this pump can handle. So in this case, this is a 6-inch discharge. The pump can pass 3-inch solids. Okay. With HVAC pumps, we tend to stay away from 1150 RPM, unless we're worried about NPSH or an open basin with atmospheric pressure that's low. But on Sump and Sewage, it's not uncommon to see 1150 because a lot of our pumps don't require much head pressure. They just require some flow. Okay, and that doesn't affect our lead time as bad as it does on the HVAC side. One thing you'll see is obviously flow rate down here on the X or horizontal axis. You'll see discharge pressure up here on the vertical or the Y axis. You also see impeller sizes. So 600 is a 6-inch impeller, 900 is a 9-inch impeller. So these are simply impeller lines. And then these diagonals over here are horsepower lines. Okay, so 1.5 horse, 2, all the way up through 5 horse. The one thing you tend not to see on Sump and Sewage pumps is efficiencies. If you've got a 2-vane impeller that's open, the efficiencies aren't very good. That's one of the reasons they're not shown on the pump curve. A Sump and Sewage might be running anywhere from 35 to 50%. So the efficiencies are how do I say it? You tend not to select a Sump and Sewage pump based on efficiency. You want to move water out of a basin, and the question is, how do you do that? Well, you pick a pump that's going to work for you. So let me just make up a duty point, and then we'll address the poll here real quick. Okay, so it's not uncommon to see some pretty ugly selections with Sump and Sewage. So in this case, I'm making up a condition of 50 gallons a minute is what we need out of our pump at about a 30-foot lift. Okay, which puts me back. We would call this to the left of our pump curve. Okay, we're not out here to the right or what we might call a best efficiency point. But notice there's no efficiencies to reference. So that takes that out of the equation. The question is, what horsepower would we use for 50 gallons a minute at 30 feet ahead? Now, most HVAC engineers, most guys who do a lot of closed loop heating systems are used to non-overloading motors, okay? Which means we take the 6-inch impeller line, which is where we would operate, and we'd get all the way to the end down here without crossing a horsepower line. And we're really close here with 2 horse, okay, to be non-overloading. But we would consider 2 horse, let's just consider 2 horse non-overloading, okay? Most plumbing engineers say, hey, I only need 30 feet ahead. I'm going to select this pump based on duty point at 1.5 horse. Now, I've already given away my poll. Well, let me share results because everybody's kind of split on this, which is fine. But let's just talk this through for a minute, okay? Similar to HVAC pump selections, all Sump and Sewage selections should be made with non-overloading motors. Now, if we have HVAC guys on the call who are cross-training on the plumbing side, they carry that mindset with them, okay? That all pumps should be non-overloading. And let me address that in a minute. I'm not trying to offend you. If you're a plumbing engineer, you're like, oh no, I'm just going to select it based on my duty point or where the pump's going to ride based on the discharge pressure or how much vertical lift I need, okay? So there's a different mindset. I just want to open up that conversation. I'm not trying to redirect anything that you're working on currently. But let's talk about why 1.5 horse might be a good selection. Okay, let's talk about how we might get there versus being what we consider non-overloading. So bear with me just a second. What we have to remember with Sump and Sewage is it's an open system. We tend to have an open pit or an open sump that's full of water, and the only job of this pump is to get water out of the basin, whatever our vertical lift is, to ultimately tie into a city connection. And the reason we see sump and sewage on commercial is we might have some loads that are below our city connection point. Okay, they might be down in a parking structure, 1 or 2 floors down. And in order to get water out of that, the bottom of the building, the only way to do it is to physically lift it. So that's the pump's job. Now, what's important with an open system? The pump is responsible for lifting water. In this case, we're assuming 30 feet of elevation from the bottom, our minimum water level in the basin, to the very top of our 90 or our bend in the piping before gravity feeds into city. We're assuming 30 foot of rise. Now, if you consider non-overloading, you're considering riding out on your pump curve. Well, if we ride out on this pump curve, you'll notice we're going to get more flow, but we're also going to get less head pressure. Okay, our open system is requiring head pressure. Meaning, if I try riding out on my pump curve, if I ride out here to not 50 gallons a minute, but maybe 150 gallons a minute, my lift isn't 30 feet, it's 25 feet. Well, if I need 30 foot of elevation and I'm only getting 25 feet, well, guess what? I've got water that's stacked in my riser, but it's not going anywhere. So this, if your head calc is accurate, then we can select this motor horsepower just based on that 30 foot of rise. We'll never see 25 or 29 because we won't be moving water out of our basin at that point. Kind of self-balances the pump if you think about it. Okay, but all that depends on your safety factor and other conditions in the field. But it's just one mindset when you're selecting sump and sewage. Okay, I'll get off of that horse. Thank you for participating in the poll. Let's talk about if we have submersible pumps, how do we physically service them or get them out of the basin? How do we deal with that? Because they're underwater, a lot of that is nasty water. We don't want to get on a ladder and head on down there. Okay, nobody wants that job. So we do something we call a removal system. And it's a little hard to explain, but I'll give it a shot. Typically what you've got is what we call a guide plate that sits at the bottom of our basin. It helps to center our removal elbows. So that's all this plate is. It's got studs on it. So your elbows mount to that. And it happens to be centered with the cover that's on the top of our basin. So we've got a guide base at the bottom, and then we've got these things we call removal elbows, like shown right here. And these simply get anchored. And then you've got discharge pipe that the contractor is supplying, and that can either go straight up through the top of the basin, or it can discharge off the side, your choice. And then we also have guide pipes, okay? And these guide pipes, again, the contractor installs these, but the guide pipes simply allow this, this removal bracket that gets bolted to the pump. It allows the pump to slide up on these guide pipes. So it's simply a friction fit down here between the removal bracket and the fixed discharge elbow. So there might be a little leakage here. Remember, we're talking pump efficiencies that aren't very high. So it's possible you might get some leakage, but essentially that's a friction fit. And when you go to remove the pump, you simply grab the stainless lift cable that's usually anchored or zip tied near the cover. You grab that, you start lifting up on the pump. The first thing that happens is the pump tips in towards the guide pipes and kind of breaks this friction fit. And then as you continue to lift up on that cable, the pump simply rides up on these guide pipes. It's not till it's free that the pump will kind of swing around. Now you can center it and get it out of your basin and take it off for service. Okay, that's how a removal system works. One thing I should note about pump selection, each pump in a typical commercial sump and sewage setup is designed for 100% service. So you've got full backup or full redundancy inside in a basin. Here we're showing different size pumps, but that's very unusual. Typically each one size for 100% of the load. A good look at a This is City of Longview. You'll notice that here's those removal pipes, okay, or guide pipes. Here's your stainless steel lift cable, okay, that's zip tied to those. You'll notice that, look at that, there's another set. So there's actually 4 pumps inside this basin. You can see 2 of them. There's 2. She's actually standing on one. There's a third over here, and there's a fourth that's out of the picture. Okay. They were getting mop heads and other debris coming in from city sanitary. So this poor lady's all masked up in there cleaning out the floats and cleaning out the basin. Not a real great environment. By the way, if anybody knows, most pumps are blue, meaning non-explosion proof. If you get an explosion proof motor, it should be painted red. Okay, that's your indication that these are explosion proof motors. Now let's talk about floats real quick, or how do we control pump operation? Simplex is very simple. Most of our applications are duplex, which means as water is rising up in our basin, these floats will raise or drop. So let's just talk about that real quick in case you're commissioning or dealing with the startup. As water comes up off this and raises the first float, nothing happens. And you might be really disappointed, but bear with me, okay? As water comes up and raises the second float, now we turn on what we call our lead pump, okay? And if that pump's doing its job, water level drops, and it doesn't shut off until this first float drops, okay? Float switch 2 is gonna drop, but the pump continues to run until float switch 1 drops. That's our off float. If pump 2 can't keep up and water continues to rise into pump float 3, now you have 2 pumps in operation. So both pumps are charging away. And again, if they're doing their job, they both continue to run until that bottom float drops. There's also a high water alarm. So if we get up here to float 4, we're going to sound an alarm on the control panel saying, hey, it's about to get interesting in here. Okay, we're about to flood your basement. You may want to have somebody come look at this thing. Okay, but that's your 4th float, is a high water alarm. You also might, for an elevator sump, you might end up with something we call a piggyback float. That's simply a float that will turn the pump on or off as it rises and falls. So really limited on the control panel there. You're just relying on float operation. You might also have a need for a probe type control, whether you have potential for hydraulic oil in your elevator system to get pumped into sanitary. They don't like that. So this controls your pump operation based on oil in the basin. You could also use this for overall pump control. It's very compact. You don't have a float that swings. It's simply probes. Okay, so that's one option for you. Another that we're seeing picking up quite a bit of action is using a transducer instead of floats. Now this transducer can attach to the discharge pipe. It can also sit at the bottom of your basin, and all it's doing is picking up water level inside your basin. An advantage of that is now you can sit outside at a programmable control panel, and based on the water height in the basin, you can tell the pumps when to turn on and off. You can tell the high water alarm when you want that triggered. It just makes life easy. You're not pulling floats in or out to adjust them. You can do it all at the control panel. A standard control panel is very simple. There's protection in there, typically hour meters to let you know that your alternator is working, and both pumps should have similar hours. The one thing that might be a little unique is a test off auto selector switch. Test is simply a spring-loaded hand selector. So the pump will run as long as you're holding the selector switch, but once you let go, it's going to spring back to off. We don't want somebody to let the pump run and then go to lunch and ultimately burn up a pump. Okay, so that it'll run for you, but once you let go, it's going to snap back into the off position. Another thing that might come across your desk is something that might call double dead front, okay, or a lockable control panel. If you're going into a public parking garage You don't want somebody in there messing with all your controls, so you want the ability to lock that panel. And that's all double dead front means, is a lockable front panel. But once you open it up, now you have access to all the controls hiding inside. Okay. So you can order these as stainless if you want them outdoors. Public space, you're probably looking at double dead front just for protection. Um, I know we won't have a lot of time to talk about this, but SCCR or short current rating on a panel is something we're seeing electrical inspectors pay a lot of attention to. Basically, how much voltage you can get if a transformer fails within your building. And we want to make sure that every control panel is being supplied with an adequate SCCR rating. So a lot of this ties us back into the electrical specification for a project, making sure that the panel has components that can handle a high inrush. Okay, just be careful if we're dealing with a new construction. You might want to make sure that we have an SCCR rating addressed. Our standard is 5K or 5,000 amps, but you can get them as high as 65 or 100, depending on how much inrush you could potentially see. All right, let's move on to basins. We're doing okay for time. Let's see how this plays out. We have some options for our basins, and I'm going to run you through a quick example. One thing that comes up all the time is how do I size a basin? How do I know the diameter and the depth, and how do I get all this to work? Normally we have 2 pumps, you have some floats. We have to make sure there's enough usable water inside a basin. Okay, so we could use a simple steel, but it's normally epoxy lined. You can also look at kind of a utility vault as a cement basin. You can go cast iron if you like. Fiberglass is another option. Typically, when there's a pour on a new site, they're just going to pour the basin as part of their concrete pad setup. If you're doing a retrofit, you might be looking at a fiberglass basin as a drop-in. Okay, that's certainly an option for you. One of the issues with fiberglass basins, it's a lot of empty air on the back of a truck. Freight rates can be pretty high here. Okay, they take up a lot of volume, but there's not a lot of weight to them. So yeah, that can be a challenge based on freight. One thing to keep in mind, typically you've got some groundwater that's pushing up on the bottom of the basin, and trying to push it out of its below grade location. What do you want to call that? Hydrostatic force. It's trying to lift that basin out of the ground like a cork. So to prevent that, you normally install it on some type of housekeeping pad with a compacted base, and then you're also going to backfill it so water doesn't have a chance to come up from underneath and push it out of the ground. Concrete vault is another option. Again, that just is going to get dropped into the space. And I don't know what this install is. Looks like a nuke plant, but okay, now we're talking. That's a pretty cool looking basin. Obviously clean water. Some rules of thumb as far as basin sizing. We can never back water up into our inlet, or what a lot of people call an invert. Okay, this is clearly where water is coming in from our building, whether it's groundwater or sewage, depends on the application. But we never want the ability or want to back water up into that invert. We have to keep that clear. The other thing we need to keep in mind, we need room in here to not only maintain some minimum water level to cool our pump or our motor, more importantly, but also some usable water so our pump doesn't short cycle, and then room to turn on our standby pump if needed, and then also to sound a high water alarm, all that without backing water up into our invert. So a good rule of thumb is about 48 inches is the space we need below our invert. And the big challenge, most people don't know where this invert's going to fall. It's not until piping's been run and slopes have been determined that everybody knows location of this invert below grade level. Every time I do basin sizing for an engineer, I do it based on the invert being here at the finished floor and let them add their invert depth to the basin calc, okay? But your choice, if you know where the invert is, we can add that to our calculation or total depth. Good rules of thumb. We want a pump to run, anytime our pump runs, we want it to run for a minute and a half is a good rule of thumb. Not more than 10 times an hour, which is normally why we have redundant pumps in the basin, so they alternate. Okay, you don't have one pump running all the time. So we just have to keep those in mind. Let's look at a quick example. Let's assume I've got 145 fixture units and I go to Hunter's curve and I establish, okay, I've got a flow in my system of 80 gallons a minute. So that's how I'm going to pick my pump. I need 80 gallons a minute of flow. Sewage application, I've got 30 feet of lift magically, okay? So I'm going to pick a pump for 80 gallons a minute at 30 feet of head or lift. In this case, I've got a 2515. That doesn't mean much to you, but it'll pass 2¼ inch solids. That's fine for sewage. Okay, it's giving me a 2-horse motor. Okay, all this is good information. What I'm trying to figure out is how much usable water I need. Well, we can make a formula look good, but basically all we're doing, if I need 80 gallons a minute, or I have a potential for 80 gallons a minute to come into my basin, and I need my pump to run for a minute and a half, well, I need 120 gallons of usable water in my basin. That's all we're trying to do. If the pump runs longer than a minute and a half, that's fine. Now, there are basin capacity charts, and they're based on a foot of depth, based on a diameter, okay? So if I look at a 36-inch diameter basin, it holds 53 gallons per foot, but I need 120 gallons of usable. So all I'm doing is taking 120 gallons and dividing it by my 53 per foot to figure out how much usable water I need. In this case, 2.3 feet, which is, what is that? 27 inches, okay? One thing to keep in mind, depending on the equipment we select, it may take up some space. It may not fit in a 36-inch diameter basin. We might need to go to a larger basin size just to fit the equipment inside. So pulling in a manufacturer's rep to help you with this is a good thing. There's some resources we can throw at you. I can tell you that 2515 requires a minimum of a 42-inch diameter basin. So even though 36 might have worked for us, I'm going to tell you, hey, we need at least a 42-inch in order to physically fit the equipment. If I know that, well, now I'm looking at a 42-inch diameter basin, which holds 77 gallons per foot. I need about 1.6 feet. And don't ask me to do that. That's 12 plus 6. That's 18 inches of usable water within a 42-inch diameter basin. Another thing that you might not be aware of, all submersible pumps require some type of minimum fluid level for cooling around the motor itself. That's how the motor gets cooled, dissipating heat into the fluid that's around it. Okay, so a lot of guys think they're going to drive water or get water all the way to the bottom of the basin. You never want to do that. The pump requires a minimum water level, in this case 12 inches. So we can put all this into a little quick sizing selection summary that says, hey, if our invert is 12 inches below grade, okay, and my high water alarm is going to be 3 inches below that, and my lag pump control is 3 inches below that, and sorry, 3 inches from my invert to my high water alarm. I've got an alarm to lag flow to 3 inches, and then my lag to lead pump is 3 inches. And I need 19 inches of usable water, okay, within my basin, and my minimum water level is 12 inches. All that totals up to a basin depth of 42-inch diameter by about 52 inches deep. Now, what I haven't looked at is what's a standard. Okay, it might be 56, it might be 60. I'm gonna get this to a factory standard, so it's probably going to be a little bit larger than this. But that's all we would do to back into a standard basin sizing. Talk about pump covers real quick, or basin covers. A standard steel cover is good to about 300 pounds a square foot. So a heavy individual could walk across this, no problem. But if you're going to use a forklift or a pallet jack, running a car across it, that could exceed the rating of that basin cover. So if it gets too heavy, depending on your load, bear with me while I launch my last poll. If it gets too heavy, we might need to have some special considerations for a cover. And that might mean you need something that's an H20 cover. Now, I always thought this was an H2O cover, meaning it's waterproof. That's not what that means. It means a traffic rated cover. Typically, these are designed for about 1,600 pounds a square foot versus 300. So they're designed to carry some weight. Different applications would obviously be anywhere where you've got a basin exposed to a parking garage or a parking lot. Sometimes they could be on a public highway or a road. There's various ratings for this. A lot of times this requires coordinating with civil to make sure they're part of the initial concrete pour, okay? A traffic rated cover is a big deal. You wanna make sure you address that early. Okay, my last little section here. We're getting close on time, and that's explosion proof, understanding explosion proof and understanding intrinsically safe controls. So National Fire Protection Agency, NFPA, has standards for Division 1 and Division 2 requirements. Now, I'm terrible at these, so I've got my next slide is a quick little summary. I hate codes in general, but anything that's got sewage in it tends to have the potential for methane gas. So if you've got a basin that's got sewage involved, most inspectors are going to require an explosion-proof motor, or highly recommend it. Okay. If we've got a tank that's storing sewage and we've got a pipe that heads to a pump that's in a separate mechanical room, which we call a dry well, okay, because the pump will be outside of the potential for methane gas, well, now you can get away with no explosion proof required. Now, there are some exceptions that manufacturers will play and inspectors might write off on, but our standard is if we know you're pumping sewage or you're dealing with some runoff water from a parking garage that contains oil or gas, our default is to give you an explosion-proof motor, just to be safe. And before I get to this quick video, one thing I didn't touch on is intrinsically safe controls. Most of our floats run at 120 volts, but if you're doing explosion-proof, we reduce that down to about 24 volts, which we call ISR, or intrinsically safe relays. It's just lower voltage, less potential for a spark. Okay. Now, I think we're all but done. Let me show you one last thing. And this is what happens if you've got methane gas in a sewer and you've got nothing to do with your time. So let me pull this over. And this is a dad who's showing his kids what not to do. Okay, this happens to be in China. I'm not picking on, this just happens to be the location. Again, this is what not to do. I'm going to turn the volume off just so there's no feedback, but you'll notice he's going to have some fun with this manhole cover. Okay, let's take a quick look at this. Hey kids, gather around. Let's see what not to do. I know that's not funny, but yeah, so the kids go running away. Now keep an eye on the cover. Here's the dad over here. Notice that that manhole cover flies up a good 3 or 4 stories and comes crashing down. That's that's the explosive nature of methane gas. And again, I apologize. I know it's not funny, but that's it's one of the reasons we don't mess around with anything that's sewage or potential for oil and gas. We don't want to see somebody get hurt or injured. Okay, so our default is, listen, let's go explosion proof and everybody stays safe. Okay, I think we're good on time. Yes, I think we are. Sunday, if there's any questions, now's a great time.
We have a couple.
Okay.
All right, let's go.
Thanks, everybody.
Are all sump and sewage motors painted red for explosion proof, or is that specific to B&G?
Yeah, good question. Most of the sump and sewage that we sell is coming from Wild Pump, and I know that's their standard. I don't know about other manufacturers, so I have to be careful on that blanket statement. Most guys are going to change a color on you, but I don't know. I'm going to tell you that's manufacturer specific. With Wild Pump, yes, all pumps that are explosion proof have a red motor attached to them.
Great. Okay, and then where do you typically locate elevator sump pump control panels?
Oh yeah, that can be a loaded question. I don't know that I have a good answer for you on that one, because it's going to depend on the inspector and line of sight. Typically, a control panel is within sight of the equipment you're working on, so most want them there so you could disconnect the power before you physically work on it. But in a situation like an elevator shaft or an elevator pit, um, you're not going to have access to that pit unless you physically pry open the elevator doors and climb down in there. So you may have some, I don't want to say it, you may have some liberty from the inspector to put the panel remote. And we've seen that on a few jobs where there's a 100-year floodplain and they don't want a panel submerged in a flood event. So that panel would go remote in an elevated mechanical room. But yeah, to me, I'm not real strong on code. That would take a conversation with the inspector to make sure you're doing things right there. Really good question. Again, bad answer.
We just got one more question.
Sure.
My understanding is that the Hunter's curve is used for water fixture units, not drainage fixture units. Does that make a difference?
Yeah, that's true. So water fixture units, I was using it in a sewage example based on how many toilets might be tied into a basin sizing. It gets different with rain and water runoff from a building. Now you tend to be talking about square foot of surface based on the roof or the parking garage. Yeah, not so much based on fixture units. So I think I've answered that question. It's a really good point. But yeah, there's a lot more to it when you're talking about rain runoff from a building. And the other real mystery is groundwater. That typically takes some type of geothermal, not geothermal, but a geo study to determine how much potential water do you have around the basin of the building or perimeter, and then account for that. So yeah, there's a little bit of black magic there, where sewage is a little bit more straightforward based on the fixtures that are going to be draining into a basin. With a roof, with rain or groundwater, it becomes a little bit more subjective.
Okay. Any other questions?
Look at that, Sunday. We lulled everybody to sleep.
Perfect. Or they're in shock. One or the other.
Exactly. As always, listen, we want to appreciate you for attending today. If there's any outstanding questions that we didn't address, happy to do that for you. Obviously, my email's there as well as Sundays, and we are more than happy to help. I want to wish you a good day and thank you, everybody.
Oh, hold on one second. Did we get another one? Oh, just thank you. A lot of thank yous. Thanks, everyone. I see everyone's messages. We appreciate you attending all our classes. Nick, Kara, I've seen you a few times. Matt, thanks for joining us today. We look forward to seeing you in the next class. Again, if you missed anything, hopped on late, we have this same session happening on Thursday. You can use the same email you registered it last time. I'll be also sending kind of a reminder as well. And the recording will be going out early next week of this class. So I hope you all have a great day, and we'll talk to you soon.
Thank you, Sunday.